Right, hello everybody. Welcome to the recap of week 3 of our FRQ questions. We're going to jump right into these ones today because these ones were tough. Okay, so if you got your butt kicked a little bit by these ones, don't feel bad. These are the toughest ones you've seen all year. Okay, there's a reason I didn't give you these on the first week review or the last week review. Okay, we're going to test your confidence a little bit in the middle of the week, then we'll make you feel better next week. All right, so here we go. Okay, first question deals with a pretty simple Scramble class, and really there's no instance variables or constructors or anything we need to worry about. We're just going to write two different static methods that dealing with scrambling things. Okay, the first one returns a scrambled version of a string. Okay, it takes a word in, returns a string out. Okay, and the second one, get out of the way here quick, modifies a list of words, okay, by scrambling them, doing some removing. Okay, so we get a array list of word strings in, and we're just going to basically modify that list. Okay, and first part to this part A, we want to write the method scramble word, okay, which takes a given word and returns a string that contains a scrambled version of the word according to the following rules. Okay, now I think big thing with this one, I gave a lot of the feedback I was giving students is make sure you understand the question. Okay, make sure you understand of what they mean by scramble. Okay, we've actually done stuff like this in the past where we did things differently. Okay, don't get too hung up on how you'd scramble a word. Take a look and really make sure you understand how the AP exam wants you to scramble it. Okay, because those two could be completely different, a little bit like we saw in our last set of free response questions as well. Okay, the rules. The scrambling process begins with the first letter of the word and continues from left to right. Okay, here's the big one. If two consecutive letters consist of an A followed by a letter that is not an A, then the two letters are swapped in the resulting string. Okay, and finally, once the letter in two adjacent positions have been swapped, neither of those two positions can be involved in future swaps. So in other words, you move on to the next set of letters. Okay, study these examples. Make sure you understand how these examples work, how they relate to the rule. Again, I had a lot of students who, were writing this method. I don't think they really understood what they were being asked to do. Okay, so first off, simple example we have, as we go through this, we have an A and a not A. We're going to flip those two letters. Okay, second example, same thing. We start off with an A and a not A, so we flip those. And then like that final rule says, we're not going to take a look at the A and the R then. We're going to move on to the R and then move through the rest of the rest of the word. Okay, so once we make a swap, we move on to the next set of letters. Okay, and then it has a few other ones, something that won't be scrambled, something that will, kind of a two A's in a row case. Again, make sure you understand those examples. Pause this and look at this for a few minutes if you don't understand them, okay, before we try to write the method. Okay, let's show you how to write that method then, and I'm actually going to show you two different approaches. One was more common, but another one a few students tried, so we'll show you that as well. So first off, we're going to return a string. So what I'm going to do is I'm going to make a new string called result. And I'm going to initially start it as the word that's passed in as the parameter. And then like I like to do just to make sure I don't lose credit for something silly is at the very end, I'm going to say return result. And I believe I could leave this blank and I could maybe even get a point for that, just return result there. Okay, so I'm going to do that just so I don't forget it. What am I going to do then? I'm going to loop through the result. And I suppose all I'm doing with this piece here is I'm telling me how many times the loop. So I suppose I could use word as well. But we're going to continually go through result and change things. Okay, now notice I have less than I in my loop counter is less than the length minus 1. And the reason I'm going to do less than length minus 1 is I'm going to make two strings, two substrings. Okay, the first one we'll be talking about kind of the letter, the ith letter we're on. Okay, result.substring of I, comma I plus 1. I'm going to make an additional substring that goes one beyond that. We'll say the second letter we're worried about is I plus 1, comma I plus 2. Okay, this I plus 1 is going to go beyond the list if I don't do this length minus 1. So that's why I need the length minus 1 there. Okay, so essentially I'm looking at the letter and then the next letter here, and I need to make sure I don't go out of bounds with that. Okay, now if the first equals A, and then I want to say the second is not an A. Kind of the quickest, cleanest way to do that is I'd say not second dot equals A. Okay, or you could say second dot equals A equals false. Okay, either way, what we want is we want an A and something that's not an A. Now, if that's true, what I'll do is I'm going to add to that, or I'm going to switch things around in my result string. And here we're using substrings like crazy. That's going to be something we review in a second here. But basically what I want is I want result to now be equal to everything in result from 0 until that index that I'm looking at, the one I'm potentially swapping. And then we're going to say plus the second letter, then plus the first letter, so we're switching the order of those. And then we need to add back on everything after that. Okay, so we'll say plus substring I plus 2. Okay, because if I was the first letter, I plus 1 is the second letter, we want to add everything on after that, so I plus 2. Okay, then one final trick for making all this work. I swapped letters. Okay, so now the A that was at I is now at I plus 1. To make sure that I don't look at that A once again, I need to add this I plus plus in, okay, to increase basically my loop counter twice in one go at it. All right, just to make sure that I don't look at that A once again. That is probably the tricky part of this one. Okay, a lot of students miss that piece. But yep, since I want to move beyond those two letters, I need to add that I plus plus. Okay, let's show you an alternative way to write this method. I'll show you kind of the issue with it, but some students did it this way. In this case, I'm going to start my result string as an empty string. I'm going to return that string once I build it. And I just switched that quick. I'm going to loop through the entire word. Okay, I can't use result in this case just because result is going to be blank. It's not the entire string we're looking for. And then I'm going to proceed in kind of a similar method. We're going to look at the kind of ith letter of word and the ith plus 1, so the next letter of word. We're going to test and see is the ith letter A and the next letter not A. And if so, what we'll do is we're just going to add letters one at a time to this. We'll say that result plus equals the second letter plus the first. So we'll add those two letters on in reverse order. Okay, once again, we already dealt with the next two letters, so I would need this I plus plus. Now, if this conditional isn't true, I still want to add a letter on, so we'll say or else result plus equals just the first letter, and then we'll move on to the next one and check the next two. Okay, this would almost work. The way I have it right now is it's going to leave off the very last letter if it's not a swap. Okay, so the reason I'd say avoid this method is that somewhere in here you're going to have to add an extra check to see if basically this part of the conditional runs, and if we're at the end of the string we need to add on the last letter. That could be done in this part of the conditional. It could be done prior to finding the second part, and you could just run through the entire thing. Okay, so this method isn't quite complete. You'd need to make an additional check for that last letter. All right, on to part B with this one. Okay, write the method scrambleOrRemove, which replaces each word in the parameter wordList with the scrambled version and removes any that are unchanged after scrambling. Okay, so basically we have a list of some words. I'm going to call scrambleOrRemove, and anything that can scramble, it's going to scramble. But anything that can't be scrambled will be removed. That's why they call it scrambleOrRemove. Okay, let's start going through this. This is a void method, so I'm not creating any variables to return. Basically what I'm going to do is I'm just going to loop through the entire array list. And I'm going to get the word from that array list. I'm going to store it as a separate variable. So string, we'll say word equals wordList.getI. And I'm also going to create the scrambled word from that word list. So we'll say string scrambled equals scramble word call on the word variable I just did. Or I could use wordList.getI here as well, but I might as well use that variable. And then what I'm going to do is I'm going to check and see, does the word and the scrambled word, are they equal? If so, I want to remove that, so we'll just say wordList.removeI. Again, that's going to remove the ith element from our word list. And then one trick that we haven't seen for a while, if I'm looping through an array list with a for loop and I'm removing things, after I remove I need to say I minus minus. Otherwise what's going to happen is I'm going to skip the next word when I make my check. Okay, reason for that is, let's say I is equal to 3. Let's say we remove that 3 in this step, the index 3. What was previous at index 4 is now at index 3. And when my loop counts up, we're going to move up to index 4. So the one that was at 4 that's now at 3 would not be checked. Okay, so anytime you're removing stuff from an array list with a for loop, you've got to add that part into it. Okay? So this would be the case when I need to remove it because the word and the scramble were the same. The word wouldn't scramble. Okay, or else what I'll do is I'm going to say wordList.setI. So we're going to reset that word that was at the ith position to the scrambled word here. Okay, few things to add to your cheat sheet. Few things I want to review. Number one, substrings. Okay, when I call .substring of x comma y, that returns a section of the string from index x to index y, not including the y. Okay, we'll show you some examples of that, but basically we're going to get a string from the xth index to one before the yth index. Okay, there's also another way to call it with a single parameter. Okay, .substring of x returns a section of the substring from index x through the rest of the string. Okay, this is handy here anytime I'm adding on just the last part of a string, or I'm using just the last piece of a string. I don't need to worry about having a comma then an expression dealing with the length of the string. Okay, if I know I want the rest of it, you just put the single parameter in there. Okay, so for example, let's say I have string stir equals computer. Okay, we'll get me out of the way. If I print out stir.substring 3, 6, that's going to give me everything from the third index to the fifth index. So 0, 1, 2, 3, 4, 5, in other words, that's why I'm getting a put there. Okay, next up, we could say stir.substring of just the 3. That'll give me everything after the third index. Okay, so that's why I'm getting the puter. Again, I could do this with a second parameter, but then I need to worry about figuring out the length. Okay, if you're using the end of the string, just use the single parameter. And finally, one more example. If I ever want a single letter, kind of like we did in this last problem, I'm just going to go substring 3, 4. Okay, that'll give me the letter at the third index. Okay, so it's not going to count up to the fourth index. It's just going to give me that P for this one. Okay, AP exam, got to definitely understand these examples, definitely understand these methods. Very good chance you're going to be using substrings in a question. Whoops, and one more thing here quick. I've got a string. I called the substring on it a few times. If I print out that string, it's the same as when I put it in. The substring method does not change the original string at all unless I use it to reassign it, unless I say string equals substring. Okay, just calling the substring method isn't going to change anything. Okay, other thing I want to put in your cheat sheet are ArrayList methods. We've had to call a few of these on problems before. We've done pretty well with them, but I think this was the first question where we called almost all of them, or a good chunk of them. Okay, so the methods for ArrayList you need to know are the add method. Okay, if I want to put something into an ArrayList, okay, ArrayLists always start empty, so if I want to start putting things into them, I use the add method. I do .add item, whatever that item is, whatever type of object it is, and that just appends the item to the end of the array list. Okay, it does also return true, which we don't really use, but it does. Okay, I could also use .add index, item, which is going to insert item at a specific position. So rather than appending, it's going to put it into the list where you want to and shift everything else up to the right, everything else back in the list. Fun fact for you, this one doesn't return anything. Okay, we'd also use the set method, and we use the set method in this one. Okay, set item index replaces the element at position index with item. Okay, so add with the index included will insert the item into that array list, whereas this one's going to just replace one single item and not add them in. Okay, we also have the remove at an index. Okay, this removes the element at position index. Okay, all elements after index are shifted left. Okay, so this just takes it out of the list and shifts everything else down the list. Okay, fun fact for you here, you could use this. This returns elements that was removed. Okay, and that'd be something if you're making two lists, like a final list and a remove list, that'd be easy to do it that way. Okay, we've been using the get method. Okay, get index returns the element at that position. We've been using the size method. Okay, big reason I want to look at this stuff here today is we used most of these within that problem. Let's take a look at all these live here. Okay, I'm going to create a array list called list of integers. And remember, when I create an array list, it initially starts empty. Okay, there's nothing in it. Let's add 1, 2, and 3 to that. That's going to give me a list containing 1, 2, and 3, just always appending that next item to the end of the list. Again, this returns true if we want to use that for some reason. If I go list.add 1, 4, that means at the index 1, I'm going to put the 4 in. So if I take this previous list at 0, 1, this is where the 4 is going to go, and then everything else in that list will just be shifted to the right. Okay, for my set method, if I go list.set 3, 5, that's going to take whatever is at the third index and set it to a 5. Okay, 0, 1, 2, 3. So this 3 was at the third index. That's now a 5. It returns a 3 if I want to use that for some reason. Okay, if I go list.remove 1, that's going to remove what is ever at the first index. So 0, 1, that'd be the 4. Notice the 4 is missing here. Everything else got shifted to the right. And stuff we've been using, list.get1, that's going to return whatever's at the first index, the 2 in this case. List.size, that returns the number of elements in the list. Okay, stuff we've been using. Okay, let's move on to our array list / array question then. The previous methods question did involve an array list. So technically there could be some overlap here, but we're hitting you harder with array and array list this week just because. Okay, and this is a classic type of question, an array list question, where basically I have a very simple class that creates a very simple object. Okay, in this case it's a horse. Okay, it stores basically a name and a weight. It doesn't even give us how these are constructed or what get name actually does, but probably just returns the name. Okay, so we have a simple object, and then our second class they give you, we have a class that basically stores a list of that objects. Okay, so the horse barn class stores an array list of horse objects called spaces. And then we're going to write two different methods. First one's actually pretty simple, the find horse space that returns the index of the space that contains the horse, that should say, with the specified name. And then the trickier one, consolidate, which consolidates the barn by moving all the horses so that the horses are in adjacent spaces, starting with index 0, no empty spaces. Basically shifts them all to the beginning of our array. Yep. All right, so part A will actually be pretty simple. Now there's one big thing I want to point out in this question, which may show up on the AP exam, may not, but if it shows up and you deal with it wrong, you're for sure losing multiple points. So that's kind of the big point of this question, why we're reviewing it today. Okay, write the method find horse spaces. This method returns the index of the space in which the horse with the specified name is located. If there's not a horse at the specified name, man, I can't spell. The method returns -1. So for example, if this is my horse barn, and let's say we call it Sweet Home. I think I messed some spacing up here. Anyways, if I go find horse space trigger, it's going to return index 0 because there's a horse with name Trigger at space 0. If I said find in horse space silver, okay, that'll give me the 2 because that's where silver is. If I say find horse space cocoa, I don't see a cocoa in here. That's why I'm getting the -1. Okay, let's write this method. We could create an index variable to return, but we can also just return the I we find here as well. Okay, so we're going to loop through the entire array of horses. Okay, so I from 0 to spaces.length. Okay, not confusing that with size if it was an array list. And in each of those spaces, here's what we need to do. Here's the big thing I want to point out here, is since a space might not contain a horse object, which is just demonstrated, there's some spaces that don't in an example there, I can't jump straight into spaces at i.getName.equalsName. If I tried to get the name of a space that is null, I'd get an error. Okay, therefore, anytime you're looping through an array where spaces could be null, and usually the AP problem is going to tell you whether or not they could be null, I need to first check and see if spaces at I is not equal to null, and then I can go check the rest. Okay, then I can go check whatever I want about the object that should be there. Okay, with short circuit evaluation, I've got the and here. If this part isn't true, we're not even going to get to this. Java will just quit this check on the spot. Okay, but yep, trick is the big thing I want to point out with this question is this null pointer idea. I got to check to see if it's null before I check and see if the name matches up. Okay, otherwise it's pretty simple. If it's not null, so we know there's a horse in the space, we'll take the space, we'll call the getName method on that object. Okay, because spaces at I is a horse object, and we'll see if that's equal to our name parameter. If it is, we'll return I. I don't need to loop through the rest of the loop because I found the horse I'm looking for. And then outside that loop, if I go through the entire loop without returning an index, we'll say return -1. Okay, one mistake I continually see from students is they put the else return -1 here. Nope, I don't want to check just index I and return -1. I want to check the entire thing. That's why this return -1's on the outside. All right, part B, we're going to write the consolidate method. This method consolidates a barn by moving horses so that the horses are in adjacent spaces, starting at index 0, with no empty spaces between any horse. Okay, after the barn is consolidated, the horses are in the same order as they were before the consolidation. Okay, again, study the examples, make sure you know what they're asking you to do here. Okay, before we start writing code, don't race the code when you don't understand what the code should do. And basically what we're doing is we're taking a list of horses with some null spaces, in other words, empty stalls in between them, and we want to squish them all down to the beginning. Okay, now one thing to notice with the example, this is almost the same list they gave you in the previous example in part A, but there was a horse named Lady here. They removed that to give you 2 null spaces in a row. If there weren't ever 2 null spaces in a row, this would actually be a very simple method. Okay, but since there could be 2 null spaces in a row, we're going to need multiple loops, makes the problem more difficult. So that's just kind of a detail you could notice as you go through this one. Okay, this isn't quite the same list as they gave me before. Why would that be? Well, now there's 2 null spaces, so I need to account for that. All right, so let's write this method. First thing we're going to do is we're going to loop through the entire list of horses, okay, all the spaces, but I'm not going to go through the last one. I'm going to include this -1, and the reason I'm doing that is I'm going to continually compare the current horse to the next horse. I might be able to get away without doing that, but since I'm using an I+1, I want you to be thinking about not going all the way to the end. Okay, and then, like we said before I check anything else, I need to check if the ith space is null. Okay, now in this case, if it is, I want to do some switching around. So if it's null, what I'm going to do is I'm going to loop through the rest of the horse barn and find the next non-null space and put that in this I space. Okay, so if we find a null space as we're looping through, we're then going to loop from j equals I+1, so the next space. Now this still would actually technically work if I start j at 0, but I'd be making Java do some extra work. But in other words, what I'm saying here is if the ith space is null, let's call j the next space, and then I'm going to loop through that, and if I come into a space that's not null, what we'll do is just make a pretty simple swap. Okay, and I don't need a temporary variable for this, because what I can do is I can put the horse that's in the jth space at the I space that was null, and I can just say j equals null then. So a few students make a temporary variable for a more official swap. Don't actually need in this one. Okay, trick with this one then is I also need a break statement. I need to get out of this loop. Once I make that one switch, I no longer want to keep looping through and changing things. I want to break out of my j loop and go back to my I loop and start looking for the next null spot. Okay, a lot going on with that one. If you got to pause the video and study that or listen to my explanation again, feel free to do that. Big thing for your cheat sheet from this one, like I said, the reason I made sure to do this question is I wanted to give you some null pointers. Okay, in Java, null is a placeholder for when a reference to an object doesn't store a value. Okay, we could say along with that, when an object is declared but it's not instantiated, it will be null. So for example, if I run the code, okay, strings are objects. If I just say string word, okay, word is a reference to a string object that doesn't yet hold a value. It has not been assigned anything yet. That object hasn't been created. We'd say that word is null. Okay, when I instantiate that then, when I say word equals, in quotes, rad, okay, word now has a value. It's no longer null. Okay, the word reference now points to a string object that holds the characters for rad. Okay, so if I don't instantiate objects, okay, we'd say they're null objects if I declare them without instantiating. Okay, well, when do we need to worry about that? The biggest spot we need to worry about is when we're dealing with arrays. Okay, because when an array of objects is created through the array constructor, so as in string objects of words equals new strings, okay, its values are initially null. They haven't been assigned anything yet. Okay, if I create it by plugging in a list, like saying it's equal to curly braces, the word rad, cool, sweet, okay, those would be assigned something right away, but when I use this new constructor, and I need timeout. No, I lied, I don't need parentheses there. So anyways, when I create this, okay, its values are initially null, I'm going to have a array object ready to store strings, but there's nothing in those. Okay, so the big thing then is when looping through an array that may contain null references, you need to check if the value is null before checking anything else. In other words, you need to make sure that there's actually an object there before we try to start calling that object's methods. All right, like I said, these ones were tough. I wouldn't expect the actual 2-question exam to contain 2 extremely difficult ones like this. So if you got some wrong, if you didn't get a ton of points, that's okay. Learn from these examples, add to your cheat sheet. The next ones you're going to see easy compared to these ones. Okay, so if you have any further questions with these examples, let me know. We can try to explain them better, try to show you how they go with your code individually. All right, otherwise, have a good one. We'll talk to you folks later.